Don't forget to subscribe and ring that bell.
Hey man, welcome back to the 2018 practice exam that College Board put out for the AP Calculus AB course. We are going to finish section 1 part A in today's video. Strange thing, there are actually 30 multiple choice questions in section 1 part A for this 2018 practice exam. That is not a typo or an error. I know previous tests only went up to what, 27 or 28? There are actually 30. So we will cover problems 21 through 30 with no calculator. Oh my. That's a George Takei reference. If you don't know, now you know. Hey. Follow me, like the video, throw a comment down there if you want to see a certain test. I'll get back to you, I promise. Let's start. 21. D over dx. So take the derivative of the integral from e to x cubed of the ln of t squared plus 1 dt. Beautiful, easy problem to start with. First of all, if I'm taking the derivative of an integral, they will cancel. And what makes this even better is there's a constant in the lower bound and a variable in the upper bound. So my derivative is going to cancel with my integral. And when the integral goes bye-bye, so does dt. And your upper bound, that variable will go in for my t. Okay? So I've got the ln of whatever t was squared plus 1. Okay? And t, we are going to put in x cubed. But please do not forget, this is like the chain rule. Whatever the upper bound was, whatever we put in here, we still need to multiply by the derivative of that. It's like the chain rule. The derivative of x cubed is 3x squared. Whoop. Now, I don't see anything below that has x cubed squared. So why don't we just simplify this part here? 3x squared, the ln of x to the 6th plus 1. Choice C. Boom. Great problem to start with. Number 22. Shown above is a slope field for which of the following differential equations? All right, and I have my options A, B, C, and D over to the right so we can see everything on one screen here. Let me show you how I like to handle these. First of all, I notice that right on the x-axis, there are horizontal slopes. Those represent little slopes. In case you didn't know, it's why it's called a slope field, right? So anytime, okay, this is where y equals 0. Anytime y is 0, I should have a horizontal tangent line. So if I look at A and if I look at B, if I make y 0, that's undefined. It doesn't equal 0, it's undefined. So it can't be A or B, okay? So right away, I'm down to only 2 choices out of the 4. And at this point, I like to pick like a section or a coordinate. And what do I mean? Let's pick section. Okay, let's pick the first quadrant here. Okay, this is quadrant 1. Okay, in quadrant 1, my x is positive and my y is positive. Notice that all my slopes are negative. They all go down in this direction in some way, shape, or form. So if I have a positive x and a positive y, I should get a negative slope. If I put a positive x in here times a positive y, I will get a positive derivative or a positive slope. So it can't be C. All right, well, let's try D just to make sure. And D is the answer. Well, let's apply how I do it to choice D. This is a negative sign, okay? If I have x, which is positive, times a y, which is positive, well, I have a negative. I have to negate a positive, which would give me a negative slope. and that's why it's choice D. These can be confusing sometimes. I mean, sometimes a lot of the slope fields can get crazy. This one wasn't too bad. 23. Using the substitution, u equals x plus 1. This is good. Okay. Integrate x over the square root of x plus 1 dx. And that's equivalent to what? Okay, let's just start our substitutions right now. And as a teacher, and how I do use substitution, I see there's going to be a little snag somewhere, but we'll deal with that when we get there, okay? So I'm going to integrate. Okay, this part, I'm going to make u. So, right off to the side here, u is x plus 1. So, I have the square root of u, because that's where x plus 1 is. Okay? And on top, I still have my x, and I have my dx here. All right, well, let's change this a little bit so it's easier. And we still need to find du. Let's find du first. So du is just going to be 1 dx. Okay, so in for my dx, I'm going to put du. But here's the issue that I saw earlier. Okay, before we deal with that, let's change things. I'm going to integrate x over u to the 1/2, because the square root of u is u to the 1/2 du. And then I'm going to bring this up because it makes it easier. So I've got u to the negative 1/2 x du. Here's the problem. How do I get rid of that x? Okay, normally, when I do u substitution, this has nothing to do with the problem that I'm doing now. It's just a little sidebar, little side example. If u equals, I don't know, 3x, and du would equal 3 dx, but I only had dx to substitute out for, we're used to doing this. You ready? I would multiply both sides by 1/3, and then I would put 1/3 du in for dx. So we are used to manipulating this. In order to get rid of this x, we're not going to manipulate this. We're going to manipulate or change this. Okay? So this is just an example, little side thing, nothing to do with the problem we're working on. If u equals x plus 1, I'm going to subtract 1 from both sides. U minus 1 equals x. Look at that. In for x, I'm going to put u minus 1. In all the work I do with my students, I never have to manipulate this one. I never have to change this one, which is weird. That makes this problem an anomaly, something we're not used to doing. Okay? Well, if I look at my answers up here, I don't see anything that looks like that. But you know what I do see? I see something with here. Okay, so I'm going to distribute. I'm going to multiply these together, and hopefully I got the same thing. The integration. This is u to the 1. I need to add exponents. If I have a negative 1/2 and I add 1, I get a positive 1/2. Minus 1 times anything is itself. And if I want, I can put these in parentheses. This is my overall answer. And that definitely is choice C. So this step right here, it made it difficult, knowing that you had to change your u equals, not your du. 24. Let f be the function given by f of x equals 2x squared plus 14x minus 16 all over x squared minus 9x plus 8. For what value of x does f have a removable discontinuity? That screams to me whole. Okay? Children, factoring never goes away. All right. I'm going to look at this numerator here. Okay, we got a fraction. I'm going to look at this numerator, and I can factor out a 2. That would leave me x squared plus 7x minus 8 all over x squared minus 9x plus 8. Okay. The top can factor. I'll leave the 2 here. And that gives me, now let's rewrite it. 2 numbers that multiply to negative 8 that add to positive 7. It's x plus 8 and x minus 1. All over 2 numbers that multiply to positive 8 that add to negative 9. X minus 8 and x minus 1. Now, do not fall for the trap. This is undefined. This is undefined at, okay, x equals positive 8, because that would make that left parentheses 0 in the denominator, and at x equals 1. However, this is not your answer, because you see what can happen? The x minus 1s can cancel. So pretty much this becomes non-existent. So what does that mean? It's not just 8. Okay, it's not just 8. Whenever I have something like this, there is a vertical asymptote right here. That is not a removable discontinuity. That's not a hole. That's a vertical asymptote. Okay? Whenever we have an x value that makes something undefined, that goes away, okay? That, my friends, is where a hole will appear in the graph. The answer is 1, and that's the only answer where we have a removable discontinuity. Problem 25. Which of the following is a solution to the differential equation y double prime minus 4y is 0? And they gave us these 4 lovely choices. Now, it's not that I have an issue with this problem. It's just that we need to think in a manner that will make this problem easy, but we're not used to thinking this way. Like problem 23, when we had to change u equals instead of du, we're not used to doing that. So for problem 25, if I want to get y equals, I would have to integrate this twice, but I'm going to integrate it with a y already there. It becomes very, very difficult to do. So what we're going to do is we're going to look at all 4 of our choices, A, B, C, and D, and we're just going to take the second derivative of both. Now, you will not get, okay, a y in the answer, and let me explain something. Let's solve for this right here for y double prime. So if y double prime minus 4y equals 0, if I add 4y to both sides, boom, the second derivative of y should equal 4 times y. Now you're looking at all these answers, and you're like, there's no way, how am I going to get a y here? Let me explain something else. Let's say y were to equal, I don't know, 5x squared. They're telling me the second derivative of y is going to end up with 4 times whatever y is. Isn't y 5x squared? So my original function, y, should show up in the derivative. Well, in the second derivative in our case. Okay? So that's what we're going to try and do. All right, so let me back this up. And let's begin. We will start with A. I know that when I take the derivative of anything e to the x, it's itself times the derivative of the exponent. So let's find the first derivative of A. The derivative of e to the 2x is e to the 2x. times the derivative of the exponent, which is just 2. That's the first derivative. What's the second derivative? Well, it's 2 times the derivative of e to the 2x. The derivative of e to the 2x is e to the 2x times the derivative of the exponent, which again is 2. So if I clean this up, I get 4e to the 2x. What was my y value? My y value was e to the 2x, and it's right here. If y equals e to the 2x, then this is basically y for my problem. My answer is choice A. Okay? If I did that process with the other 3, I would not get 4 times my original equation of whatever y is. It would not happen. That's a very different way of doing this. Number 26. Oh, I love graphs and tables and charts. Oh my. Let's take a look at what 26 has to offer. The table above gives values of the continuous function f at selected values of x. If f has exactly 2 critical points on the open interval from 10 to 14, which of the following must be true? Must means not could be true, but must be true every single time. It's nice to know that it's continuous because there's no breaks in it. And it's got exactly 2 critical points. That means our slope is going to change exactly 2 times. Not at most 2 times, not at least 2 times, but exactly twice. So I like to visualize this. Okay, so here's the x. There's the y-axis. Here's the x-axis. Okay. And we're going to have the following x values at 10 through 14. Okay. 10, 11, 12, 13, 14. So I'm going to plot these points, and they go as low as 2 and as high as 6. So 2, 3, 4, 5, 6. All right, so 10, 5. When x is 10, y is 5. That's right here. 11 is 2. 11 is 2. It's right down here. 12 is 3. That's up 1 here. 13 is 6. It's way up here. And 14 is 5. That comes back down. Okay, so I know at some point it's coming down, coming back up. It's something like this. Here's one critical point. Here's another critical point. There are my 2 exactly critical points. It's continuous. So I shouldn't have dashed it. I mean, it might not look exactly like this, but that gives us a good idea. Now, f of x, okay, f of x is greater than 0 for all x in the open interval. Yeah. Let me read that again, kids. F of x is greater than 0. That means our y value for all x's in the open interval from 10 to 14. Based on what I drew, okay, it looks like that could be the case, but it doesn't have to be the case, all right? For example, I could have drew something that came down like this, and came down like this, and came up. This little section right here has a negative y value. So it doesn't have to. Doesn't have to be true. Okay? So let's get that out there. Where are you? Right there. Okay, so this doesn't have to be true at all. It could be true. It doesn't have to be true. So f prime of x exists for all x. Just because it's continuous does not mean it's differentiable everywhere. I could have a corner or cusp in here. I could, okay, let's do this in red. I could have this come down nice, then come up to points. That could be a cusp. It could be. It doesn't have to be. It could be. So it doesn't have to be true. Boom. So let's get rid of this red graph. Okay. C, the derivative of f, which is also the slope. Okay, let's make this clear. This means slope is less than 0 for it's all a negative slope. That's not true. It has to go from this point up to here. So at some point it has to be a positive slope. This is not true. My answer is this. F prime of 12 cannot be 0. Yeah, it can't be. Because look at it, here's a low point and here's a high point. Okay, it has to go from this low point to this high point, which means it has to be going in an upward direction when at x equals 12. It cannot equal 0. This must be true. Okay, and you could say to yourself, well, what if, Visca, what if, let me get rid of all these. What if I came down here and I came up and 0 then came up? Well, then you'd have a third critical point, wouldn't you, where x is equal to 0? Exactly 2. Choice D. Number 27. The positive variables P and C change with respect to time. The relationship between P and C is given by the equation P squared equals 20 minus C all cubed. At the instant dP dt is 41 and C is 15, what is the value of dC dt? All right. Well, first of all, in order to get dP, we need to take the derivative of P. And in order to get dC, which we're solving for, we need to take the derivative of C. So I think the first thing we should do is take the derivative of our equation right here. So if P squared equals 20 minus C cubed, all right, let's just go ahead and take the derivative here. This is 2P dP dt, okay, equals exponent rule, the 3 comes down, the inside stays the same, this drops by 1, then times the derivative of the inside, which would be just negative dC dt. All right, let's start plugging in what we know. We will go here, go here. Let's go purple. We know C is 15. So we have 20 minus 15 squared times 3. That is a minus sign. All right. We're finding dC dt. So why don't we do this? We'll bring down dC dt. That's what we're finding. The minus sign we'll put out front here, the negative sign. So this should be an unknown right here. We're solving for this. That's what they're asking us to solve for. All right. So then on the left side, let's go back to our purple. I have dP dt is 41. We have our 2, but the question is, what about our P? We don't have a value for P. And in order to solve for dC dt, I need a P value. I cannot have 2 unknowns. So what we're going to do is we're going to take our C value and plug it into here, our original equation, and solve for P. So let's go up to the side here. I got P squared equals 20 minus C all cubed. Well, C is 15. So 20 minus 15 cubed, which is 5 cubed, which is 125. P squared equals 125. So let's take the square root of both sides. And I'm going to say that P equals, all right, well, that's the square root of 25 times the square root of 5, which will just give me 5 radical 5. All right? Now, you might be saying to yourself, Visca, anytime I undo a square root, shouldn't I have plus or minus? You should, with the exception, positive values for P and C. Positive. So I don't want the negative version. It should just be positive 5 radical 5. So in for P, I'm going to put 5 radical 5. Now I have only one unknown, which is dc dt. And we're just going to use opposite math, combine like terms, do some just simple algebra here. Here. Okay, this again is 5, and I need to square it, which would give me 25, times my negative 3, which is negative 75 dc dt, equals. All right, well, I'm going to multiply these two together and get 82 times 5 radical 5. There's a reason I'm not multiplying my 5 in. And that reason is, I know I have to divide both sides by negative 75. Divide this by negative 75. I know 5 goes into 75 easily without having too big a number in the numerator, because remember, we don't get a calculator. I could have multiplied 82 and 5 and reduced it. But at this point, I know 5 goes into 75 15 times. Okay, it still would have reduced to the same answer if I would have multiplied 82 times 5. All right, so my answer in all of its glory is 82 radical 5 on top over negative 15 on the bottom. Okay, so let's write that out nice and clean. (82 radical 5 over 15, and it's negative. That's dc dt. And if I look up here, woo, will you look up here? Will you look at that? That, my friends, is choice D. Ooh, 28. 27 was a little bit of a doozy. So let's just go right into 28. Find the limit as x goes to negative infinity of 3 plus 2 to the x over 4 minus 5 to the x. Don't fall into the trap that they're trying to set here. What do I mean? You are plugging in negative infinity. Okay, negative infinity. Anytime we plug in infinities, we like to keep the biggest term in the top and bottom. And we like to think that just because it's an exponent here, I'm only going to end up with 2 over x and 5 over x negative. But resist that urge. How come? Because when I'm throwing in a negative infinity, especially throwing a negative value into exponents, it does funny things. What do I mean? Well, I have 3 plus 2 to the negative infinity. I'm going to go ahead and plug that in. All over 4 minus 5 to the negative infinity. What do we do with negative infinities to make them positive if they're in the exponent? Let me ask it this way. What do I do with negative exponents to make it positive? I cannot just take this term and flip it here because it's connected with a plus. I cannot take this term and flip it up here because it's connected with a minus. They are not individual terms all on their own. They are connected with pluses and minuses. So I cannot just do that. But what I can do, this is technically over 1, and this is technically over 1. So what I have is 3 plus. Now I'm going to take this and move it on the bottom of its own fraction. 1 over 2 to the infinity, all over 4 minus. I'm going to take this and move it to the bottom of its own. 1 over 5 to the infinity. You should realize at this moment, and it's at this moment, the calculus student knows he done messed up. Because this and this, both of those fractions, the bottom grows faster and faster than the top, which means this is going to approach 0. And the bottom here is going to go faster than the top, which means this fraction altogether is going to approach 0. 3 plus 0 over 4 minus 0. is just 3/4. Okay, 3/4. I mean, look what they have here. It's crazy. Not 0. Okay, if the bottom grows bigger, it's non-existent. Really very simple when you look at it as the 2 to the x and 5 of the x is their own terms that you need to flip with the negative exponents. 29, 2 more problems, 29 and 30. 29 says, well, it doesn't say this, but I love that there's a picture of a graph. 29 reads, the graphs of the functions g and the line y equals x are shown in the figure above. The graphs intersect at the points 0, 0, 1, 1, and 2, 2. Which of the following expressions give the area enclosed by the graphs? We have these 3 options. And if I scroll down a little bit further, it's either only 2, only 3, 1 and 2, or 2 and 3. All right? So let's kind of start to analyze this graph based on the information they gave us. First of all, G. Now let's do this in the thick. Yeah, I got that. G, and then we have y equals x. Well, y equals x is the straight line here. Y equals x. That will be in red. In green is G. That's G. And they intersect at 3 points. And they give us those 3 intersection points at 0, 0. So this is 0 on the x-axis. At 1, 1. So this is 1, 1 on the x-axis when x is 1. And at 2, 2. When x has a value of 2. All right. So first of all, I'm looking at the following. All of my integrations from 0 to 2, all right, I am going to take, for number 1, it says the absolute value, all right, the absolute value of x minus g of x from 0 to 2, all right? Here's a problem with this first one. They have x on top minus g of x, okay? When I say y equals x, I'm saying they have the red line, which is y equals x, minus the green line, which is just g of x, from 0 to 2. The problem is, notice that between 0 and 1, the green line is on top. So that should be the bigger function minus the smaller function, which is the red line, x. Okay, in fact, let me do it this way. It is g of x minus just y equals x. So I should integrate this from 0 to 1. All right, and of course there's a dx. And I should add that to the integration, okay, from 1 to 2. Now the red line is on top, so that's the bigger function, okay, minus the green line is below. See how the green line is below the red line from 0 to 2, or from 1 to 2? Okay, g of x. And then we have dx here. So the problem is, this will give you 2 positives. How come? Because the bigger function is listed first between 0 and 1. Bigger function between 0 and 1 is the green one, g of x. The bigger function is listed first between 1 and 2. That's x. X is the bigger function between 1 and 2. It needs to be written like that. So right off the bat, I know that choice 3 is an answer. Okay? Anything that does not list choice 3 should not be good. Bang, bang. So now 1 cannot work. Okay? It's only 3 or it's 2 and 3. Now let's look at the difference between actually option 1 and option 2. Option 1, okay, option 1 does the absolute value of the whole thing, but it always leaves x on top, meaning x on top is fine here. The red is fine here because the red is on top. But look at here, the red is on the bottom. So it's still going to find the difference. It's going to subtract those. It's not going to add those. You'll get a smaller value, and then you're going to take the absolute value of the difference of these two. It's not combining them. You won't get a big one, so it can't be 1. Okay? We already knew it can't be 1. But what's the difference when the absolute value bars are outside or inside? Okay? Choice 2 is actually a valid answer as well. How come? Because it's taking the absolute value of the functions before we integrate. Meaning, let's say if I have x on top, okay, anytime the red is on top, which is right here, I'm going to do this in a, let's go this let's go this deep yellow. Okay, it might show up as an orange on your screen. When the x is on top here, that will give me a positive value. When the x is on the bottom here, that will give me a negative value because I have it listed first. But since my absolute value is inside the integration, it will make this negative positive before I integrate it, which means it will combine them, and you will get a total area between the curve. For this first one, it's going to combine the positive and it's going to combine the negative. Then it's going to take the absolute value of whatever this is combined. This one takes the absolute value of the plus, takes the absolute value of the minus, and then combines them. I don't want this. I don't want to add a positive and negative first, which is what choice 1 does. I want to make this positive, and then add them. That's the difference between having the absolute value bars on the outside versus on the inside. So choice 2 is a legit response. Yep, this one right here. 2 and 3. Number 30, our last problem, and as I'm reading this is like an Algebra 2 or an Algebra 1 question. A student attempts to solve a differential equation, dy dx equals x times y cubed, right? With the initial condition, y equals 2 and x equals 0. The steps of the student's solutions are shown below. Which of the following steps does an error first appear? Well, we're just trying to find someone else's mistake. That is a Algebra 1 or Algebra 2, maybe even a geometry Regents question or a final exam question, not a calculus one, but it deals with calculus work, so I get it. All right, let's go here. Let's end with something nice. Let's go with this nice soft blue. Okay, so first of all, they divide both sides by y cubed. That's why you got this with the dy. And then they multiply both sides by dx. So we have x dx. Yeah, that's an x. I swear to God, kids. I swear. Don't hate me. Let me rewrite that. On the right side, we have x with our dx. And on the left side, we have 1 over y cubed dy. Oh, man. It's been a long day. So this is correct. Okay? Here's the issue. When I integrate this, okay, now I want to integrate both sides. The integration of this is just x2 over 2 plus c. Okay, that's good. But when I integrate this, I'm going to have to do u sub, where u is y cubed and du is 3y squared dy. And I don't even have that. I can't even do this. 1 over y, the integration, would be the ln of y. Okay? In fact, I'm not even going to do this. I'm just going to change 1 over y cubed to y to the negative 3. So when I integrate that, it's y to the negative 2 over negative 2, which would ultimately be 1 over negative 2y squared plus c. It is not this. Okay, it is not that. Right? Not at all. Yeah, I wouldn't even do that. I just got my mind stuck on the only way I can use ln is if this is 1 over u or 1 over y. The minute the exponent is bigger than 1, we need to flip it up and just use the power rule to integrate. All right. So that's the first. The error happens in step 2. 30 questions. These were long videos, the last 2. But you know what? We're going to go into section 1, part B, I think. I don't know. The multiple choice questions where we get the calculator. Those are going to be coming up. You know what? Today is November 22nd. This is the last day of school for us before we go on Thanksgiving break. So whether you celebrate Thanksgiving or not, I'm not sure. Depends on, I guess, if you're in the Americas, North America, the U.S. or not. And you know what? Stay healthy. Eat a lot of turkey and gravy and mashed potatoes. And let's go Dallas Cowboys. That's my team. I'm sorry. I like the Bills too, but the Cowboys are 1, Bills are 2. And follow me on YouTube, ring that bell, subscribe, leave a comment if you will. Have a wonderful holiday.
Don't forget to subscribe and ring that bell.